going to give you a quick walkthrough of some cloud compliance and entitlements use cases that my customers are implementing today using Armory Policy Engine. I'm going to start by giving you a high-level overview of the Policy Engine ecosystem. I'm going to start by telling you what Spinnaker is and how our customers are leveraging it. I'm going to tell you what Policy Engine is, and then I'm going to tell you what Open Policy Agent and Reggo are. I'm going to explain how all of these components come together in order to fulfill these use cases. Once we've covered the high-level ecosystem, we're going to dive into several of these use cases. We're going to break the use cases down into two different families. We're going to start by talking about compliance use cases. These are use cases, for example, to enforce SOC audit controls. They ensure that a company stays in compliance to their internal policies as well as regulations that they need to comply with. Our second set of use cases is going to be around entitlements. These are very much related to who is allowed to do what. So without further ado, let's hop over into our high-level overview. So Spinnaker is an open source deployment platform. It allows you to deploy code to any of the major cloud environments. So it can deploy to Amazon Web Services, Microsoft Azure, Google Cloud Platform. It can also deploy to Kubernetes. And it adds a lot of advanced capabilities on top of that simple deploy. So for example, you can really easily do a blue-green deploy. You can really easily do a canary deploy. And Armory Policy Engine is a plugin to Spinnaker, and it adds some robust policy capabilities to Spinnaker. So Armory Policy Engine basically instruments everything you can do within Spinnaker, and it allows you to write policies against them in another open source framework that is called Open Policy Agent. Open Policy Agent can execute policies. Its policies are written in a language that is called Reggo. And then it also outputs what's called the decision log. And the decision log is an audit history of every policy decision Open Policy Agent has made. So every time you do a deploy with Spinnaker, Armory Policy Engine reaches out to Open Policy Agent, and Open Policy Agent makes a note of what the policy check was, what infrastructure were you trying to deploy, as well as was that deploy allowed to happen? What was the decision? While we are going through our use cases, I'm going to be showing you some Reggo scripts that implement these use cases. So Reggo is a fairly different language from many of the languages you have probably used in the past. So this is going to be a high-level primer of some things that, if you understand about Reggo, will help you to follow along on those policies. So the first thing I want you to know about Reggo is that it uses a different structure for its if statements than any other language I've used in the past. So, instead of having kind of if, then the condition, and then the statement that happens if that condition's true, it reverses it. It starts by putting the statement that only is evaluated if the condition's true, and then it puts the condition in your squiggly brackets. So here you can see this statue equals true. That will only be evaluated if the curly brackets evaluate to true. Here you'll notice I have two sets of curly brackets. So the reason for that is inside of a set of curly brackets, all of the conditions are ANDed together, but you can have multiple sets of curly brackets, and those will be ORed together. So in this case, it will set statue equals yes if the city is Paris and the country is France, or if the city is New York. So you can think of this as being a statement that will say statue equals yes if there's a Statue of Liberty in that location. So the next thing I want you to understand about Reggo is that it doesn't have a looping construct. So you can't do a while loop, you can't do a for loop. It replaces this with a shorthand that allows you to say, does this value match any other value? So at its simplest, you'll see this value equals array square bracket underscore square bracket. And what that underscore means is try every single value, and this statement is true if any value in that array matches this condition. So it will simply check every single thing. Coming down here, this sum function, this is for find some value of I where all of these values are true. So this will return true if in this has statues array, there is any element where both city and country match my city and country. So this allows us to, with just these 3 lines, have this rule from up above, but it's not going to match on New Yorks that are not in the United States. So finally, for rule number 3, with this, any value syntax, things get complicated when you want to negate it. So Reggo forces you to be very explicit anytime you are doing, negation around this, find any value syntax. So, these 2 functions on the left are not valid. And the way you do negation in Reggo is you make a function. So you make a function, in this case, it's called inArray. And you have that not have any negation. And then you make a second function call that just negates it. So you'll see me using these functions and then calling not and then the function on a fairly regular basis throughout the examples. And that is just how you do negation in Reggo. The last thing that's a pattern that you'll see is there will be a few places where I am using this object.get function. And the reason for that is in Reggo, if you reference a variable and it doesn't exist, then that condition will always evaluate to false. So you can't, for example, say, hey, if this variable equals null, be true directly. The object.get function, it allows you to specify a default value to give back for the variable if it does not have any, if it does not exist. And this value allows you to very easily do a null check. So anytime in these policies I'm referencing variables that may or may not exist, you'll see me using object.get. And the reason for that is object.get lets you reference something that may or may not exist. So those are some basic things for Reggo that I hope help you follow along in the example. Without further ado, let's go into our first family of use cases. These use cases are things customers are doing in order to ensure that their production environment runs in line with their policies, in line with their regulations. It's not about like who is allowed to do what, but more what code are we okay with running in production at all? So our very first example use case, I'm keeping this one fairly simple, simply checks to see if a particular pipeline stage exists in any pipeline that's going to deploy to production. So if a customer wants to deploy to production, they need to do this stage. In this particular example, I'm using the manual judgment stage. We do have customers who do stages other than manual judgment with this type as well. It can be done with any stage. So later on, we will cover a more powerful version of this example because this version is just checking whether the stage exists. It's not caring about things like stage order, for example. So let's walk through how this policy works. So this first line specifies what type of policy it is. So there are several different types of policy checks that Policy Engine will run, and they have different pieces of data that you can write your rule against. So the OPA.pipelines package is the package you use to write policies that occur when a pipeline is being saved. The next thing we have here is the list of what accounts we consider to be our production accounts. There's several different ways in Open Policy Agent and in Reggo to specify pieces of helper data such as this. This is the simplest, so we're going to use it in this example. But there are some other approaches that we'll talk to later on in the presentation as well. Here we have our actual rule. So this rule is going to deny and provide back this message to the user if this condition is true. So you're going to see this pattern in a lot of these examples. The condition we're checking in this case is we're looking for any value of j So if this value exists such that it is a deploy manifest stage where the account is in our list of production accounts, and there is also no manual judgments. So these last two lines, this is a shorthand that basically builds an array of every stage where the type is manual judgment. And this guy just counts how many items are in that array. So, if I don't have a manual judgment and I've got to deploy to a production account, then we deny. That's it for this use case. And now we have enforced that no pipeline can deploy to production unless it's got a manual judgment stage. For our next example use case, this one's around tagging and annotation. So a lot of companies, when they're adopting the cloud or they're adopting Kubernetes, have challenges with making sure they know who owns and is responsible for every piece of infrastructure that's deployed. And a lot of companies implement, tagging or annotations in order to have this visibility, but then they have the challenge of enforcing that all of their application developers are actually tagging everything they deploy. So this policy allows us to simply prevent any deploy from running if it would deploy infrastructure and would not set one of our company's required annotations. So in this case, we're running this before any deploy manifest stage. So depending on what cloud you're using, there are different stages. This one would be for deploying a Kubernetes manifest. In a lot of the examples I go through in this presentation, I'm going to be using Kubernetes as an example. Here we have, again, the list of what annotations we require that users have set. And then down here, we've got the condition that if it's true, we will not allow this. So what we're going to do for this is we're going to go through all of the annotations that are in the manifest, and we are going to simply read from that annotation every required annotation, and if it's set to null, we're going to fail. So the instant that any of these annotations is set to null, this whole thing will evaluate to true, and the user will get back the error that it is missing a required annotation. For our third use case family, this is quite similar to the last use case. So, we want to go and analyze a manifest when it is being deployed and ensure something is true. But the last one was kind of a internal visibility best practice. This one's really more around ensuring our production environment stays safe. So a lot of companies have requirements for data encryption in transit. And for data encryption in transit, how you ensure your data is encrypted really amounts to which protocols are you using. If you're using HTTP, it's not encrypted. If you're using HTTPS, it is. So this policy simply prevents a large number of services from being exposed for their unencrypted versions. So this will block HTTP, which is port 80. It will also block several common alternate ports for running HTTP, but you'll notice it allows HTTPS, which is port 443. So, this will block all of these services. You'll notice that this rule is doing 3 checks that are ORed together. There are different types of Kubernetes manifests. So if you're deploying a service versus if you're deploying a pod, where the path in the manifest is to ports is different. So in a service manifest, our ports are in this spec.ports section. And then inside of that, you can have a port or a target port. So we're checking to make sure neither the port nor the target port is in that block ports list. For a pod, we have a container port that a container in that pod can expose. So we're making sure that there are no container ports that are in that block ports list. A pod template is used by a Kubernetes deployment or a Kubernetes replica set. So again, for a pod template, we check for container ports in the pod that the template will create. So if any of those situations are true, if any of our ports are referencing items that are in that blocked ports list, we will again give back the error message. The last use case I want to share with you in this kind of compliance family is integrated process checks. So imagine that you have a security scanning tool. A lot of these tools maintain lists of what they've scanned. So, we have a process where we deploy Docker images, we run a security scanner on them, and when that scanner is done, it makes a note that, hey, this particular image has been approved to be used. It passed the check. Or, if issues were found, maybe it didn't pass the check. So we have customers who in Spinnaker deploy pipelines where they will stand up a new image in staging, run their security scanner, then decommission staging, and then finally try to stand it up in production. And on that production check, these customers add a policy that goes and queries the security scanner to make sure the image has been scanned and was approved by the scanner. So in this case, I'm not maintaining the list of approved images in the policy because it's changing frequently. I am attempting in this example to read the list of approved images from the Reggo data document. The data document is a document that you can upload into and then can be referenced from your policies. So it's got a simple API and you can hook it up to, for example, your security scanners. An alternative that can also be done is Reggo does allow you to do simple, HTTP REST API calls from within your policy. So there's two different ways to kind of do this integration to your security scanner. Either you can call its APIs from within your policy, or you can have it when it finishes a scan, upload new data to Reggo that specifies the list of approved images. So here, again, I'm running on those deploy manifest stages. So anytime we're going to deploy a manifest, and I've got two helper functions down here. Is the image in the list of approved images? It's just going and checking that array. And then I've got, is the image unapproved, which is just doing that not function. All of the checks here are just asking whether or not an image is unapproved. The difference between them is the path. So, I mentioned on the last example that depending on the kind that's being deployed, the path in the Kubernetes manifest for report change. The same is true of the image. So for pods versus pod templates, there is a slightly different path for your container image. So this checks your normal container image. And then in Kubernetes, you also have init containers, which are containers that basically can start up and do things like, for example, copy files around and then go away after kind of initial configuring of the pod. So we're also checking to make sure our init containers have been scanned and are on the approved list. So if any of our containers anywhere in our manifest are not on the approved list, this will give back that rejection. And this again forces that your scanner has run and approved every image before it can reach production. For our second use case family, this is a class called Entitlements. These are very focused on who can do what. And we have different customers who are doing different rules around, which actions are they trying to restrict. But these are all rules around who is allowed to do what in the company. Our first example is going to be high-level restricting an action by a role. So in the Spinnaker UI, for an application, you can open the Clusters tab. And the Clusters tab will show you what infrastructure is running for your application. And it allows you to click on any deployed pod or any deployment, and it allows you to edit that deployment. So you can say edit, and you can literally just inline edit the Kubernetes manifest. You can also choose delete, and it will completely delete your deployment for you. Or you can choose scale and tell it, hey, I need more pods. So a lot of our customers want some of this functionality for some users, but they don't want everyone to have access to it. So this particular example takes one of those tasks and it makes it so that that task can only be run by admin users or users of a particular role. So here we have two helper functions. So the first helper function is this hasRole helper function. And the hasRole helper function just checks to see whether or not that role is in the list of roles that the user who is attempting this action has. The second helper function checks to see whether or not the call is attempting to create a task of the particular type. So this post to the tasks, this is checking whether or not it is calling the Spinnaker tasks API. And then this is simply confirming that, you know, the task that is being called is the one that's desired. So the rule goes ahead and uses those helper functions, and it checks to see whether or not they are creating a deploy manifest task. This would be the task type that is created when you hit that edit button that I mentioned. Delete manifest would be the task type created if you tried to delete the entire infrastructure. And it will only allow it if the user is an admin or if the user has the desired role. If either of those is true, then it will be allowed. If they're both false, then the user will get back this message and will be denied access. Our second entitlements use case that we have a lot of customers doing is enforcing which accounts are allowed to deploy to which namespace. This allows you to put in a control that ensures every app is running only in the namespaces that are intended to be used for that application. So here we have a helper function called canDeploy, and it takes a namespace in an application and it just checks to see whether or not they exist in that map. So then for our security rule, we read the namespace in the application that is attempting to be deployed to, and then we just check if it's not in the list up above, we give back this error message. If it is in the list, it's allowed. And that's how we do our namespace and our account enforcement. So finally, for our third and final entitlements use case. This one is actually a hybrid. It's both an entitlements use case and a compliance use case. So a lot of our customers have audit requirements where they need to maintain separation of duties. So the user who implemented a code change cannot also approve that code change into production. And many of these companies have multiple different sign-offs that need to happen. So in this particular case, I have a rule that I don't want code deployed to a production account unless it has had a sign-off occur from my information security department and from my QA department. And in this case, those are manual sign-offs. I could, you know, integrate to a security scanner as well if I wanted. And it's really important to me that those sign-offs happen before it is deployed. So unlike our earlier example, this example cares about the order of the stages in the pipeline. So how does it work? So this stage graph data structure reads the input, and the input contains a series of stages, all of the stage data for the pipeline that is being executed, or in this case, saved. And that stage data is in a native Spinnaker format. So this code here creates a data structure called stage graph, and it is in a graph format that is easy to use in Reggo. Specifically, it's in a format that we can use to check whether or not a node is reachable from a different node. So it allows us to very easily, using a Reggo function, say which stages are earlier in the pipeline than this stage. We then have two other helper functions. This first helper function takes the index of a stage and it takes a role and it returns true or false. Is there an approval by that role earlier in the pipeline than this index? And this is running that graph analysis that I mentioned in order to make sure that it only looks at earlier stages. For roles, we're looking at the selected role of the stage and also making sure that only one role can approve that stage. So we want to ensure that both QA and InfoSec have approved it. So that's going to be 2 separate manual judgment steps, one for the QA role, one for the InfoSec role. We then have this function of lacks earlier approval by, and this is literally just doing that not trick that I mentioned earlier. So for our rule, we will go through every stage, and for every deploy manifest stage that is deploying to a production account, we will fail if it lacks an earlier approval by either the QA role or the InfoSec role. So if either of those roles haven't approved it, we fail. If they've both approved it, then we don't give back the error message and the user is allowed to deploy. So that is an example of how you can have maintenance of separation of duties and enforce that multiple specific manual sign-offs have happened before code can touch your production environment. So I hope you now have a understanding of, what Spinnaker is, what Policy Engine is, as well as Open Policy Agent, and that you have a feeling for how these tools can help you to maintain your company's policies as code. I hope you also have a feel for some of the common use cases that I see across our customers. And with luck, several of them were things that you yourself identify with and wish you could enforce automatically in your own production environment. If you would like to learn more about Armory Policy Engine and how Armory can help you maintain your company's production policies as code, please don't hesitate to reach out. We'd love to give you a demo. Thanks. Any questions? Yes, Jesse. So a list of all locations the Policy Engine can be evoked was actually just added to our online help yesterday. So it lists every single one of the packages, and if you just search for Armory Policy Engine, it'll bring up the guide. There is, at a high level, the ability to trigger at the start of the execution of any pipeline stage. There is also the ability to trigger on any save pipeline or any API call from the UI to the Spinnaker APIs. There are also some policy checks that can be implemented to turn on and off certain UI buttons based off role. And Andre, Sentinel is very specific to the HashiCorp stack. If you're using Terraform and you're doing everything through Terraform, it's a great option. If OPA started largely in Kubernetes, so you can use OPA via Kubernetes admission controller, and Policy Engine uses OPA because it basically was, when we looked at it, the starting point that looked like it would work best with the largest range of technologies. And Policy Engine is specifically OPA on top of Spinnaker. And then the announcement that I was asked to make during the Q&A is that there is a car in the parking lot that has its lights on. The license plate number is CDROKS. The car is a code by the manufacturer's secret. So if you drive a secret code with the license plate number CDROKS, your lights are on. Did anyone else have any other questions they wanted to ask? Cool. So if you're interested in learning anything more about Policy Engine, or if you think of another question you have on this session, I will be manning the Armory booth at about this time tomorrow morning. So feel free to stop on by. And if that time doesn't work for you and you want to know more about any of this, if you stop by and ask someone else, I'm sure they'll be willing to help you get in touch with me. Oh, can OPA policy work on AWS CloudFormation templates? Yes, but it depends on how you are deploying to AWS. When you are deploying to AWS, you can have your templates as part of your Spinnaker config, or you can read the configuration from S3. So, for example, we have a customer who is doing reading ECS task definitions from S3. The situations where you're reading config from S3, you are not currently able to write OPA policies against, but all of the stuff that is actually going through the Spinnaker pipeline, you can. So yes and no. For the most part, yes, but there are exceptions. Anyone else have any questions? And does that answer your question, Gaurav? Yes. So I on Terraformer with OPA, I put out a blog post. Want to say a couple months ago that used OPA and Terraformer. There are also in the package list that I mentioned for which packages you can do. One of those is policies that trigger before a Terraform execution stage, and all of those packages do have some example policies in there. So I believe there are some with Terraformer, and you can you can definitely reference OPA policies for your Terraformer stage. So Sudeep, there are not currently any Katacoda labs. There is an AWS Quick Start that I know just became available for getting Armory Spinnaker stood up in AWS. There's also if you look at something like Policy Engine, if you've got normal open source Spinnaker deployed, it's fairly easy to turn on Policy Engine to try out, and we can also get you, a hands-on sales demo. So if you stop by if you stop by the booth, we should be able to go over some of the options there. So Jesse, the data.approved images, the way that's passed into policy execution is Open Policy Agent has what is called the data document. And the data document has a API for uploading to anything in it. So anytime you see data.something in Reggo, that basically is referencing a piece of data that is uploaded via OPA's API as opposed to being maintained in the policy. There is also an ability to call external REST APIs from within an OPA policy. So we do have some customers who upload to the data document, and we have other customers who have their policy reach out and call APIs. Sudeep, that is a great ask. If you get me your contact information, I can probably get you something there on the comparison to Azure policy. At a high level, when you look at OPA or Sentinel or Azure policy or AWS config rules, a lot of them can be used for similar things, but most of the other solutions are very technology specific. Policy Engine gives you kind of a single central place you can define all of your policies, regardless of which cloud you're running on. There is also an advantage that we have over several others in that most of the other products in the space deploy your infrastructure and then flag it as violating policy, whereas Spinnaker and Policy Engine allows you to check the policy violation before you deploy and prevent that deploy from ever running if it would cause a policy violation. So Jay, Policy Engine in OPA does not natively have a way to validate the dependencies. However, the way we have customers doing that is in their Spinnaker stages, they will deploy to a staging environment. They will run a set of security scanners. For example, you can use the Docker scan command or the SNCC security scanner, which is what Docker scan uses under the covers, in order to go and scan your Docker image chain. And then they upload scanned images that pass the scan to the OPA data document for that approved images list. So it's an enforcement mechanism, but it is not itself a scanner. So you can use it with any of the other scanners on the market. Cool. And Sudeep, I will reach out to you later on today. Did anyone else have any questions? If not, we'll go ahead and wrap up. Cool. Thanks, everyone. I hope you found this useful. And just to make sure everyone caught it earlier, there is a car in the parking garage with its lights on. It is a secret code with the license plate number CDROKS. And if you're trying to remember that license plate number, it's in the QA chat, so you can copy it out of there as well.